Hi everyone, welcome back to the final part of the TripApp series. If you've been following along, you already know that in part 1 we built the splash screen, and in part 2 we created the main screen and connected to Firebase Realtime Database using MVVM architecture. In this video, part 3, we are going to complete the user journey. We'll walk through the search and result screens, where users can select their travel options, pick a date, and see the matching trips retrieved directly from Firebase in real time. Let's dive right in. Let's start with the search activity.kotlin file. This screen allows users to choose where they are traveling from, to, and on which date, plus select the number of passengers. Right at the top, we're initializing view binding with binding equal activity search binding dot inflate and set content view with the parameter of binding dot root. This gives us access to all of the layout elements inside Activity Search XML. We're also connecting to Firebase with database equal Firebase database that get instance. This let us fetch location data from the locations node in Firebase. In the function init location, we set up a reference to Firebase. Then we listen for data using @listener for single value event. For each location we receive, we convert it into a location object and add it to an array list. Once Firebase returns the list, we populate the Spinners drop-down menus for, from, and to. So, if you add new cities in Firebase, for example Chicago or New York, they automatically appear in the app's Spinners. This makes the search screen fully dynamic. No hard-coded cities, no manual updates. Now, looking at the layout file, Activity Search XML, we designed the screen to be simple and modern. At the top, there's a header with an icon that changes based on category: train, flight, boat, or bus. Then come the from and to spinners for location selection. Next, we have the passenger section, where users can increase or decrease the number of adults. And finally, two date pickers for the departure and return dates, followed by the search button. When the user taps on the date field, we open a date picker dialog, format the date using a simple date format, and display it on screen. This gives the app a professional feel, just like real travel apps. When the user presses the search button, we call this code. This sends all the select data to the result activity, so that screen knows exactly what to search for. And now, let's open ResultActivity.Kotlin to see how it processes that information. Inside Result Activity, we again connect to Firebase, and we then create a query. This line tells Firebase to look for trips where the from field matches the user's chosen departure location. Then, inside on data change, we loop through the results. So, it only adds trips where both departure and destination match the user's choices. If any results exist, we display them in a RecyclerView using the same trips adapter from earlier. This keeps the UI consistent and saves us from writing new adapter code. In the XML layout activity result, the structure is clean and minimal. A RecyclerView to list all matching trips, a progress bar in the center which hides once data is loaded, and a back button to return to the previous screen. Once Firebase finishes sending data, the progress bar disappears, and users can scroll through available trips, complete with company logos, prices, and travel times. It feels smooth and responsive, just what you want in a travel app. What makes this setup so powerful is that Firebase handles all the filtering for us. Instead of downloading all the data and filtering it manually, we use Firebase queries like orderByChild and equalTo to fetch only the relevant results. This makes the app faster, more efficient, and scalable. If your Firebase database grows with hundreds of trips, this approach still keeps the app lightweight and fast. We also include a small but important UX detail. The passenger counter updates dynamically with plus and minus buttons. The date pickers prevent users from choosing valid past dates, and the back button cleanly returns to the search screen using finish. These touches make TripApp intuitive and polished, the kind of app users actually enjoy using. Building the search and result screens was the final step in completing TripApp. This part really shows how Firebase, MVVM, and clean Kotlin code come together to create a real-world Android application. Through this project, I learned how to handle Firebase queries, manage live data efficiently, and design smooth navigation between multiple screens, all while keeping performance in mind. And that wraps up the TripApp series. We've gone from the splash screen to a fully functional travel app that connects to Firebase in real time. If you enjoyed this project breakdown, don't forget to like, comment, and subscribe to support more Android development tutorials like this. Thanks for watching, and I'll see you in the next project.